So let's continue with the example that you stop at the stop sign and you see the bus approaching at 5 miles per hour. And when you look at the bus, it seems you are backing up your car. It was not, but it's about the relative velocity concept. So we apply the equation we just learned. So here we want to see how the relative velocity of the car, which is A, relative to the bus, which is B. So we start with V A equal to VB, the bus, plus V. If it A start, then it will be A relative to the bus. And then if I project this vector equation in the x-axis, in this case, it will be the horizontal, or if we talk about the road, it means the eastbound. So let's talk about project that equation in x direction, eastbound, and let me assume go to east is positive. So from that, VA equals 0. So we can write that equation at VA 0. So VA equal to VB, 5 miles per hour to east. So 5 miles per hour, 5 miles per hour to east, right? So it's positive, same at positive direction. And then you can plus the relative velocity V A relative to B in x direction. And from that equation, you can have VA relative to B, which is the relative velocity of your car or you on the car with respect to the bus in x direction. We can have equal to negative 5 miles per hour, or 5 miles per hour go to the west. It means as if you are backing up. So that example to show you the importance of the relative velocity. So with that, let's move on to the acceleration. So acceleration. Of course, we take another derivative to get the acceleration. Another derivative from that, we have d over dt velocity. So v, from the equation we have relative velocity equation here, vb. So it will write down vb vector equal to d over dt va plus d over dt v b relative to a. So the first derivative of velocity with regard to time, it will be the acceleration. So from that, I can have a of particle b vector is equal to a of particle a plus acceleration of particle b or object b relative to particle a or object a. And that one, we call it a relative acceleration equation. Relative acceleration equation. Keep that in mind. So it's very important. So what is AB and AB relative to A? So similar to what we learned in the velocity, the definition of VA, VB, and VB relative to A, we have the same here. So let's write A, acceleration of particle A, acceleration of particle B. So basically, it will be the absolute acceleration of A or B, measure with regard to x and y, a fixed axis. Measure with regard to x and y. So a fixed axis, for example, the car with regard to the road. And the relative velocity acceleration, A, B relative to A. So this is a relative velocity. So it means that we have an acceleration, relative acceleration. So in this case, acceleration of B as if A was not moving, as if, or fixed, right? As if A were fixed or not moving. We're not moving. So that's the concept of the relative acceleration equation. So how to solve the relative velocity equation or relative acceleration equation? Let we talk about procedure, and then we can apply to the problems. Procedure. How to solve this problem. So there is 3 items that we want to keep in mind. The first one, we need to specify A's. Specifies A, point A, particle A, E, origins, for translating axis, X apostrophe, Y apostrophe. Okay, so what is that? You can solve it in here, in that translating axis, and the XY is the fixed axis. So for translating axis, and for this point, normally we know velocity or acceleration. So this point usually has known velocity or acceleration, depends on the question asked. And then the second note that we need to keep in mind when we solve for the using relative velocity or relative acceleration equation, for each equation, either relative velocity equation or relative acceleration equation which are discussed, at most you have 2 unknowns. At most 2 unknowns. For each relative equation, 2 unknowns. What are the 2 unknowns? Typically have it either magnitude or directions. Of velocity, if we're talking about the relative velocity equation, or acceleration, if we talk about the relative acceleration equation. So keep that in mind. At most 2 unknowns for one relative equation, because it's vector. You can have 2 equations from a vector equation project to x and y axis, for example. And For one vector, we have magnitude and direction, and consider those are the two unknowns. And then the last note before we move on to the solving problem either can be solved. How can we solve relative velocity equation or the relative acceleration equation? So how can we solve? We can solve by either way. Can be solved either two methods. The first one, graphically. And the other way is more we solving here in this class is resolving into components, x and y, basically into components. And then we show with the x and y, so it's scalar equation. So you have x and y components, and then we can solve for scalar equation. And so we can apply the both method graphically and resolving into components and scalar equation in the first problems, and then the other three problem we will do with the components and scalar equation only. With that, move to the problems.